Hey guys, so anyway, I'm doing this live on my personal YouTube channel because it's probably impromptu and
Hey
I
guys, so
think sorry. Okay, yeah, I needed to mute my desktop. Sorry. So anyway, I'm trying to figure out how do you do a live chat on the phone. Oh, okay, I see. Okay, so let me just get myself set up. Um, Okay, so today we're going to look at the Silicon Labs TinyGecko 32-bit starter kit. I actually received this quite a couple of weeks ago, actually. And basically, this was part of the two product samples that the Silicon Labs team has sent me. But if I'm being honest, I did tell them that I need more variety in order to plan the lab series because they just sent me two of the same product. So not a lot I can do with that. So, instead of just waiting for them to send me the rest of the sample, which they will in the next couple of weeks, I believe. In the meantime, yeah, I'm just doing this for the fun of it. And also, I guess I have a lot of things on my mind right now. And sometimes playing around with electronics kind of helps me to relax, so that I don't think so much about all the other things that are going on, the stress that I'm experiencing or all the different things. So anyway, today we're going to cover a couple of things regarding this development board. Um, what we're going to do is also, at the very beginning of this session, the very first thing we want to do later is that we want to solder um, the pin headers, right, to the Gecko started the development board, all right? So that is the first thing that we're going to do later. You will notice that this is actually a little bit different from your standard pin headers that, if you were to buy from, say, a normal electronic uh, hardware store, all right? The length is customized, if you notice. This is actually from the Semtech uh, brand partner that we have. So I'm just going to put it here. All right, so I actually got this from Semtech. Let me see if I can adjust. Okay, so I got this from Semtech. All right, so if you are interested, Semtech they allow you to customize the different configuration and settings of your pin headers and sockets and cables. So it's a really really good brand, and I honestly feel that you should go for them if you can. Especially if you are moving from basic electronics to something more advanced, and if you are designing your own PCB boards and you have specific spacing between the pin, right, the pin slots, right? If you need specific spacing, you can look at their pin headers, all right? You can order in bulk from them. They do provide like product samples, so you can also take a look at that and check it out. Right. So the thing is this. Yeah, I didn't include some text link inside the description, so I'll probably add it in, after the live session. I hope I remember that. But yeah, you can use basically any pin headers that you have as well. It's just that I kind of like the idea that I can add additional length at the bottom, so that if I'm using a digital oscilloscope or even a say a logic analyzer, I can clip onto these pins because they are still quite long, right? So even after I solder later on, there's still gonna be some space left. So that's a good thing that I like. Right, so this development kit, right, comes with this LCD display, which I really like as well. So we can do some fun projects with it. And later today, later in this session, we are going to download and set up the uh, Simplicity Studio together. install it, and then we're gonna get started with some getting started projects. Now, I have to be honest that I never played with Silicon Labs products before. Like some of you, you are probably first timer looking at this and knowing about this, learning about this. So am I. So we're gonna learn about this product together today. All right. Okay. So the first thing that we want to do, I'm gonna just move the camera a little bit and show you. Okay. So I actually have this RS components, RS Pro uh, soldering station. I bought it a couple of months ago. Let me try to focus it and show it to you. Okay, I'm just move the camera a little bit. Okay, so I have this RS Pro soldering station. I actually really like this soldering station, by the way. It's not too fancy. It's easy to use, simple, and we're gonna power it up. Okay, so what I like about this is that you can set the channels, the settings, right? And you can adjust the voltage, right? So it's already set at 350, so you can change the channel settings, so you can save. So you can select the channel that you want to use and set the temperature as well. So most standard soldering station, the recommended temperature for doing your soldering is actually 350 degrees. All right. So in this current setup, what we're going to do is, okay, I'm just going to adjust. Okay, so let me get a cable out of the way. I don't want to let it get burned. Okay, so what we're going to do is I'm going to do some soldering. And then, okay, so a couple of things that you might need if you are doing this for the first time or if you're not familiar. I would always recommend getting a flux pen. My favorite tool is so cheap. You can buy it online on any website. Doesn't cost much. And also the other thing is that you might be able to see. I don't know if I can focus it if it's close. Okay, so you will be able to see that there are like this little area around the pinholes, right? That is where you can place a flux, and then when you solder, the solder will eventually rest around the rim. All right. So it was that is the point of contact as well. Okay, so we are going to put it upwards. The pin header will be upwards. I think it's also good to put it this way because when you want to plug in your solderless wires, your breadboard wires, it's very easy to just put it from the top instead of from the bottom. So we're going to flip this around. Okay, now, okay, first thing we want to do, we are going to apply some of this. I probably have to manually focus the webcam every now and then. Yeah, this is not the most ideal setup for me, honestly. I used to do this with a good DSLR camera or even a video camera, and I can easily adjust it. But I'm using a webcam, and I can't really adjust it, so I have to do it by hand and bring it closer, and so on and so forth. So yeah, it's not ideal. But I guess I just make do with what I have, right? Anyway, one of the things I want to talk about while I'm doing this is that I'm also right now having a crowdfunding campaign. I'm trying to raise funds for a workstation, a custom workstation that online lab series can use for all the future lab sessions, research and development, so forth, all the work that we're going to do. And, I would need a pretty powerful workstation. So um, that campaign is on Indiegogo. You can look at some of my previous videos in this channel. I did talk about like some of the FAQs and so on and so forth. So you can actually look at it, and it'll be great if you can back my campaign. All right, I need to raise about 35,000 actually. So um, yeah, hope that people will actually back me on the campaign. I set a campaign for 7 days, but if I can, I hope to see some results, and maybe I'll extend the campaign even longer. All right. Okay, so let me just flip around so you can look at this. Okay, so another thing that is good to take note is that if you are soldering with like this little, if you are doing it with wires, you can use a thicker solder, but I am using a much thinner solder with the flux core, all right? This is actually a 0.4 mm solder, all right? So we're gonna use this. All right, so the first thing we want to do is, of course, we want to thin the head of the solder. I haven't soldered for a couple of weeks or maybe months, so I think my soldering iron is oxidized already. So if you have no idea how to thin, right, just put the solder at the tip, right? So solder. I think that sometimes when you're doing thinning, use the thicker solder. Right, it's much easier. The thin ones are not exactly ideal for soldering, for thinning. Sorry. By the way, I'm a self learner. I'm self taught on electronics. I don't have a degree in electronics engineering. So anything that I know and am doing now, it's really through self learning. All right. So now that we have thinned the wires, we're gonna start doing some soldering. So one tip that I can share, if you watch other videos, you probably learn this as well, is to start with just one pin first. All right. So we are going to keep that head around. Okay. My soldering skills are still not as good, so some days I can do it really well, and some days just I don't know, not that good. Well, somehow it's just not. Maybe I should just use my thicker solder. Feels like that is the answer I need. Okay, that's clearly quite ugly for the first one. Oh well, let's do it for the other end. Okay, so normally what I do is I just want to check that the whole thing is flat, all right? So there are no gaps. So that's what we're going to do. Mhm. So it's well and secure. Nice. Okay, so another trick is that what I do is I always do um, both ends first, so that it's easier to like move towards the inside. Okay, so now we have both sides sitting nicely flat. So let's see if I can get this Chinese solder to work. Or is it because my solder is too thin? Yeah, feels like the solder is too thin. Oh well, that sucks. I guess I'm a bit of a perfectionist, right? So I will try my best to do the perfect solder each time. But because I use the much thicker solder, it seems to get all over the bottom side of the header pin. So if it comes to clipping it, yeah, I guess it'll be a little bit difficult. Honestly, when I look at myself doing this on my mobile phone, which I have just over here on my right, which you won't see on your on screen. Yeah, it does look like I'm actually doing much better than when I first started soldering quite a while ago. And sometimes, I somehow get a kick out of doing soldering. I don't know, it seems to be quite stress relieving. It's somewhat therapeutic too. Mm, I'm gonna take some more soda. Be right back. I guess the thin solders are probably more suited for SMT devices. I don't know. I got this for like really, really thin one. Okay, so this is actually the thicker one. Mm, okay, let's finish soldering. Okay, so just expecting the solder to make sure that it's well balanced. Yeah, sometimes I realize when you don't solder properly and the connections are not good, the wires can't seem to pass the signal properly, when you're doing the development, right? So I always check to make sure that there's a good amount of solder coverage. So okay, so it looks like we're done. I'm gonna put the soldering station aside for now. Then the let's inspect our solder to see if it's done well. Let me try and replicate this. Okay, it does look like um, there's space for me to clip my wires if I need to. Okay, yeah. So you can see that my soldering skill is not perfect, but I guess I get a job done. So all things considered, I guess it's not too bad. Okay, so let's start powering. Download the software bits, and then we'll come back to the hardware to look at it again. Right? Okay, so everything is done. Headers in nicely. Okay, next, I'm going to start sharing my screen. Before I share my screen, I'm just going to turn off the notifications. Okay, so yeah, I got the notifications turned off. Um, I'm just going to share the entire screen. Actually, I can just share the window. Okay, so now you should be able to see what I'm looking at. Okay, I'm going to I put the links in the description for this live video as well, so you can follow the links. But if you need the links, I can paste it in the chat window, right? And you can download them. I've set the live session, the pre-recorded session to uh, play back the chat as well, so you can sort of follow along with the information, right? Okay, so this is the Simplicity Studio 4, and we will set it up together. You need to have a Silicon Labs account, so once you have done that, right, you'll be able to install. It's a good thing that I have a fast internet. Okay, I'm going to share my entire screen. I think it's much easier, so that I don't have to turn it on or off again. Give me just 1 second. Okay, so we have the file in our downloads. We will look for Simplicity Studio. Now there's version for Windows and Linux, so you can install the relevant version depending on what you're using. Right? I'm running on a really humble Mac, so honestly, I try not to use the Windows VM unless I absolutely need to for live broadcast for online lab series. But yeah, it really drives my laptop insane. Yeah, it drives my laptop insane when I try to, uh, you know, set it up. Okay, so once everything is set up, we can find the Simplicity Studio in the applications. If I'm correct, I think this is they created a version based on the Eclipse branch, all right? So it's one of the Eclipse branch, and then they took it and adopted it for Simplicity Studio for Silicon Labs products, right? Hmm. Did I change my password? Okay, let me try changing the password. All right, cool. Yeah, I'm setting this up for the first time, guys. So honestly, there are things about this environment that I'm not familiar with clearly. So it's a bit of a trial and error as we figure this out together, guys. Anyway, it seems like I'm the only one watching myself. It's just me. But I don't know. Maybe somebody might join the session later. It's a weekend. Somehow I feel like people are probably not going to be watching the session. Who knows, right? Wonder what's wrong. Okay, so apparently there is update software. Install by connecting or selecting devices. Okay, let's try that. There will be a USB cable that comes with your development kit, right? It's from the box. So um, yeah, we'll connect that and then we will continue with the setup. I really look forward to having a proper setup so that I can actually, you know, show the hardware and also uh, show the desktop screen at the same time. But yeah, right now, this is all I can do. You see the screen, but you not see the hardware. So it'd be nice to have like a real camera, you know. Yeah. Huh. I've connected my device, but let's try to see the EFM32. Okay. It's connected. But, um, well, it feels like it's going to take a little while. Let's see how long it takes to load. Okay, my laptop is starting, the fan is starting to make those noises again. Seriously. What is going on, man? So slow. I'm going to just force quit the application and start again. Please back my campaign, guys, so that I can get a custom workstation I need. So that I can, provide a more, how would I say, better learning experience for you guys. And at the same time, while doing live stream, I won't have to go through all of this. And sometimes it's a bit frustrating because when things hang and there's not enough RAM or There's so many applications running in the background. It's quite frustrating, honestly. So I'm trying to acquire the Orion X by Overclockers UK. Now the thing is that they did offer to sort of help us reduce the price if we can, raise some funds. I could raise some funds through. Uh, so if I could raise some funds through crowdfunding, they would sort of give a discount and reduce some of the costs. Yeah, it could be a good thing, honestly. You know, but yeah, this is the frustration that I get sometimes when things doesn't work. Let's hope the installation works. In the meantime, while this is running, I'm just going to pack up my soldering station and keep it. You know, my desk is already small enough, and I'm kind of dreaming about the ability to make over my room and turn it into a sort of a bedroom plus studio plus uh, workshop. But I have a mom who's a control freak, so if I want to revamp the room, if I want to make over the room, I think she's going to freak out over it as well. So hey guys, while the installation is still running, I was typing some things inside the live chat, and basically to encourage people who's watching the rebroadcast or even a live session, if you can see the messages, to sort of help back my campaign, my Indiegogo campaign to raise funds for the customer station by Overclockers UK. All right, so if you're watching this, you'll notice how much time it actually takes for me to run all the setup and everything, and it's really, really slow on my MacBook. Um, and even though, I'm not honestly not running a lot of applications at this point in time, but the thing is that my MacBook is this fan is starting to make some noise, and it's pretty obvious. I'm not even running VM right now, so um, yeah. I really hope that people would back my campaign so that I can really upgrade my setup here, so that I can also be able to do a lot more things that I intend to do through online lab series, providing better content, and so on and so forth. I think that's the main thing, to provide better content, right? And that's the thing. This is a live session, right? It's just a pre-recorded video. I can fast forward, and kind of speed up the whole process, and you don't have to wait. But I also want to do live broadcasts as part of online lab series, because the live broadcast is very good for the younger audiences, the younger viewers, right? Most of the younger viewers, um, they're probably younger than me. So I'm not saying that I'm old, but those that are younger than me, they are into live streaming these days, and that's the trend that people are going towards. So if you really want to reach more viewers, and you want to encourage more young viewers to pick up electronics, or to pick up the products that the brands are sponsoring us for online lab series, you have to cater to the younger crowd. You cannot expect them to fit into what we want. I think at the end of the day, if you really want to build a platform that serves these people, you have to observe what makes them happy, right? What they would enjoy the most. Sure, I used to do a lot of pre-recorded videos, tutorials, technical tutorials, live, as in recorded videos. These recorded sessions. My experience is that it's actually much easier doing that. Although I probably have to record it a couple of times, rehearse it a couple of times. For me, I'm getting a lot more natural in pre-recorded videos. Um, but the thing is this: in pre-recorded videos, there's no sense of a live Q&A. There's no way for people to really uh, there's no way for people to really understand, or if they have questions, sorry, I mean, if they have questions they want to ask on the spot, you know I can be there to answer it on the spot as well. And I think that's the key benefit of having a live session as well. Another thing is that having a live session means people who want to, if they have a desire to follow along with the lab series, they can do that, and they can ask questions as they are learning, and that interactivity is one of the good benefits of doing a live broadcast. And contrary to what some people might think, I did a lot of research. All right, the fact that I've done actual studio environment setups, and I've done pre-recorded videos, and I watched a lot of live streaming sessions people have created, professional live streamings. The thing is this: the really good ones, technical guys, especially these are technical videos, is not about product info. So it doesn't have to be that professional. But of course, it has to be better than what I'm doing now. But it's all about having some fun, right? Something interesting. And one of the things that I find is a downer if I'm watching my own videos now. Um, if I were to be critical towards myself, honestly, what I have now, I think it would be a little bit boring doing the video because there are stretches of time and periods of time during the live broadcast that it's just slow. So people are just waiting for the next thing to. It's like waiting for a shoe to drop, and the shoe doesn't drop. So that is probably one of the downers, I guess. So yeah, honestly, I would love to have a much faster system with more processing power, more RAM, to be able to do things a lot more faster. Yeah, that's what I really want to say. But yeah, if you're watching this, let me know what you think about the live broadcast part of the experience, learning experience. Yeah, I guess it's debatable, right? Some people think that live broadcast is good. Some people think that live broadcast may not be good. So I guess it's up to an individual's preference. But yeah, doing live broadcasts and then also having pre-recorded sessions to tag with the tutorial articles sort of makes it allows online lab series to target a wider group of audience. So that's what I'm trying to go for, and not limit the audiences. So anyway, I'm just trying to talk because this fetching installation unit screen is still going on and it's taking a while. Okay, so what I was just doing was I was trying to take a photo of um, the screen. I'm just gonna post it on Twitter and sort of share with people about how slow my system is. I'm actually using the mic from my webcam, so pointing it down seems to make the sound quite muffled. So I'm going to try and talk towards the webcam more often. Hmm. It looks like it's still just me watching myself. So I'm gonna go post something on Instagram for now, and we'll be back to check on the progress information in a while. Okay, so it looks like the installation manager seems to be fine now. So I will connect the cable up and then we'll try to set up the software. Let's see if we can find. Hmm, 32 bit. Wow, how much space do we need? Mm, Let me try and connect the USB cable again. Oh, is it because we need to try to figure out what we need to do? So anyway, this TinyGecko is part of the TinyGecko 1132-bit microcontroller. It runs on the ARM Cortex M0 Plus MCU. Um, so it's good for energy efficient IoT applications, which is good if you want uh, to set up a project that can run in a remote location for a very long time without the need to replace the battery, right? It has so there is this wake on touch capacitive sensing technology. So we will look at the hardware and the bit after we run through some of these features. And so there's the LCD, the segment LCD that we saw earlier. There's the CAN bus controllers, which is one of the communication protocols. Okay, so up to 48 megahertz. All right, so like your standard Arduino, if you have used Arduino before, you know that Arduino is running on 816 megahertz, right? 16 or 20? 16, yeah, 16. So then this is like 4 times the speed. Is it? 16 times 232. No, yeah, roughly 2.5 times the speed. So there's a wake up interrupt controller, which is good because if you need to do certain events and you need your the board microcontroller to respond to certain events to perform a task and then return to the original task that it was working on. This is also good. And the wake up interrupt, I think this wake up interrupt is actually meant for like when you want to wake up the device to do certain things. I think so. We'll probably have to check out documentation to learn more about this. Energy, probably don't understand half of the acronyms here, so it's something that we'll have to figure out and learn as well. RAM retention, so this looks interesting. Probably it's related to being able to retain whatever um, information that is being stored in the RAM. It feels like that's what it means in deep sleep. Deep sleep current. So this is the amount of current that it consumes when it's in a deep sleep mode, which is 1.30 microamps. It's actually quite little. It's very, very small. It's not such a small amount. So honestly, even for a coin cell battery, I think it can really last very long. So if you try to use a 9-volt battery, oh my goodness, you probably only need to change it once in a very, very long while. Integrated DC to DC buck converter, up to 128 kilobytes of flash program memory. This is something that I think is worth highlighting because after I've worked with Arduino for quite a while, for some time in fact, you realize that actually when you start reaching like 64 kilobytes or even say 32 kilobytes of flash memory, it's actually quite a lot. If you know how to design your program, if you know how to design your firmware, the architecture of your firmware, and you really follow the best practices, honestly, it's a lot of memory. So for 128 kilobytes of flash memory, you can write a pretty big program, and then load it inside. 32 kilobytes of RAM is honestly quite a lot as well. So that's always a good thing. So we have the CAN bus controller with communication speeds of up to 1 megabits per second. UART, that's 4 UART. It also includes UART for smart card as well. Some of these things I'm not very familiar. I'm not electronics engineering major. I didn't even took a degree in that. So, and then low energy UART. I think this is also one thing that's important. So we'll focus on that. I2C support. There's up to 67 general purpose I/O pins. Okay, so when I'm looking at the board, maybe the pinouts, together with the LCD, I guess. There's also a row of pins, a double row of pins, pin headers on the side of the board. So that probably covers the I/O pins as well. There's direct memory access controller. Honestly, when I hear myself saying all this, um, just a couple of years ago, I honestly would not know anything about what's a direct memory access controller, and it still amazes me that I'm able to understand all of this now. Some of it, at least. Probably not as good as some of you who's more experienced in embedded systems or electronics. But yeah, a lot of the things I know now are self-taught and self-learned, and I'm still doing that every single day. And honestly, tell the truth, there are still things that I don't really fully understand. I'm not a very theoretical kind of guy, but I'm more hands-on. So I kind of figure out like what do I want to do, what sort of project, what sort of problem am I trying to solve. Then based on that, I look at what is of concern. What do I need to know about the product to solve that problem. So I don't learn everything about the product uh, normally. But for the purpose of online lab series, I really want to teach people and share with people, not teach, but share with people or potential product users on how they can actually maximize all the features that are available in a particular product. So on that note, it gives me the opportunity to also really dig into each of those features and functionalities that are available. So this is also a very good chance for me to really learn as much as I can together with you guys, right? Okay, so timers, frankly speaking, I've never really applied timers in any of my projects so far. But yeah, we can explore some of it, and see what we can really do, something useful and real world with these timers and counters. Low energy sensor interface, autonomous sensor monitoring in deep sleep mode. So I would think that, when you integrate it with sensors, right? So we talk about wide range of sensors supported. So if you have sensors running and you need to gather data, you still can monitor the sensors data that is reading the data input, right? Even when it's in deep sleep mode. I guess that's what it means. So if you're thinking of getting it, this is actually the price. I believe it's in USD, right? So USD $90 for this starter kit. Mm. Let's read the user guide. Let's figure out how to really work this. Yeah, before we get into the hardware, let's look a little bit at the hardware as well, all right? Okay, so I will need to manually refocus. Okay, so let's look at some of the features that are available on this hardware development board. Okay, so we have the breakout pin headers that we have soldered earlier this in the session. This is where you connect the USB cable. Then your coin cell battery is here. So this little switch here is for you to toggle between running on the battery, or I think this will actually be the USB, right? The two LEDs. This is the capacitive touch, so you can respond to a capacitive touch, I believe. Okay, so we'll probably have to program it. Here's the main MCU, all right? The reset button. We have the LC sensor. I think this is the LC sensor, right? We can look at the documentation later as well to verify all this information. I think there's another piece of sensor here, right at the top. Right, if you look at the side, I think this is another sensor. So later when we look at documentation, we will know more about this. There are a couple of other things here as well that I'm not too sure what they are. We will probably have to learn about them as well together. And so yeah, we have two buttons that we can play with on the development board. Let's flip over to see what we have underneath. Are there anything underneath? Yeah, probably not. Okay, let's switch over to the documentation now. Okay. Okay, so you should be able to see the screen. Well, looks like nobody's really watching yet, so I guess I can probably take a break to sort of post this on uh, Instagram. So Okay, guys. Sorry, I was taking a break earlier. I was actually posting something on the my Instagram feed, so people know about the live session. Okay, so let's get back to what we were working on. Okay, so here's the documentation. So here it says it is the SLS TK 3301A starter kit. So it apparently this is a very good way to get started with the 32-bit TinyGecko microcontroller. So you can see all the specs here, right? So this Sega, I hope I pronounce it correctly, even if I pronounce wrongly, my apologies. This Sega J-Link onboard debugger. Now the good thing is that I'm using the platform IO development platform or embedded system development platform by uh, yeah platform IO. So I know the founder, all right, the CEO. Awesome tool to be used with Atom IDE. So you can build electronics project, code electronic projects using that. That make use of the IntelliSense and so on. So that is really good. And then also on top of that, they have a debug capability. So you can actually, I know that they're compatible with J-Link debuggers. So it's probably good, using the environment you can code and then do debugging in real time as well while your project is running. So that's something good. Okay, I realize that you are not seeing my screen. Sorry about that. Okay, so let's continue. Okay, so yes, the sensor that I was showing you, this one here, this white little patch here, this is the Silicon Labs SI7021 relative humidity and temperature sensor. Um, this this 7210 over here is the Hall effect sensor. Now, honestly, I myself I don't really know the purpose of a Hall effect sensor, so let's find out what this is. Okay, so apparently, let's look at Wikipedia. So Hall effect sensor is a transducer. Is a device that converts energy from one form to another using a transducer converts a signal. Okay, and varies its output voltage in response to a magnetic field. Uh, Used for proximity switching, positioning, speed detection, and currents. So I think in the particular use case for this speed detection, clearly, talk about mobility projects. Say like my e-scooter, the e-scooter that's sponsored by. Sorry, my mind went blank. Falcon PEV, right? They are local Singaporean distributor for all of the really cool e-scooters and e-bikes. So say I decide to want to measure the speed that the e-scooter is going, I can probably use this, right? Positioning, I'm not too sure what this positioning is. But I guess we can figure it out along the way. Okay, so under the applications, the sensing of presence of magnetic objects connected in position sensing, um, those operating units. used in brushless DC motor to sense the position of the rotor and to switch the. Okay, so so something that we might know, smartphones use hall sensors to determine if the flip cover accessory is closed. Huh, interesting. Okay, so let's go back to the documentation. Okay, so blah 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 blah. Then we have, okay, yeah, software support. So we have installed Simplicity Studio, and then we also have the IAR embedded workbench. I do have that as well on my system. But honestly, I'm not very good with using this. In a way, I'm still sort of getting comfortable around it. Yeah. Mm, functions and features. Let's see if this link works. It's a 404 though. I thought that, I wanted to share this, with the Silicon Lab guys. You should take a look at this because I think that the link is broken. And, if people are trying to figure out and learn more about product and they go to a broken link, it's a bit disappointing though. It's not exactly a good experience. So please take note, guys. Point 1.3 getting started under the documentations for this Silicon Labs starter kit. Just take note that the getting started link is a broken link, guys. Okay. Right now, I'm just trying to figure out the software part, right? How do we work with it? Um, this is great, IO pins. But right now, we are probably not concerned with this because ultimately, the first thing we want to do is just to set up the software development environment. Um, let's try the getting started. Let's see what happens. Okay, they have a quick start guide, so let's try looking at that. Okay, sign in. So we have done that. I need to maximize. You guys might not be able to see this very well. Okay, so I pretty much have done the first few steps. Uh, kit registration. Kit number. Um, okay, so it says that the registration is on the box. So let me get the box. Okay, so I think this is the. SRS. Okay. 309. Oh, it needs the serial number. Okay, so the serial number is one. So your serial number should be different from mine. I think so. Awesome. So now that we have registered the kit, let's proceed with the next step. Um, okay, update software. Hmm. Yes, ma'am. Okay. Okay, so already registered. Let me check the documentation again. Okay, so we can install the hardware driver. I believe that's what it is. Okay, this is awesome. One of the things I'm concerned about doing this installation is that if it requires a lot of memory, and my laptop memory is honestly dwindling down right now. All the different tools and softwares that I have installed. Oh, I'm running out of space. I really need to upgrade my system. Please, guys, please back my campaign. Uh, yeah. Hmm. Hmm. This Okay, guys, at the Silicon Labs, this evaluation license. Um, just a quick shout out. Can you guys sort of like help me get the licenses so that I can continue using it for the online lab series later on, and it won't sort of like expire. So yeah, and yeah, thanks in advance. So there's a video that you can watch, but I'm not going to play here because on my system it's just going to create a feedback loop of the audio and it's going to be very noisy and messy. So we can watch the video, all right? I'll probably watch this video later on. So anyway, I placed the video, the live video links on my various social media accounts, but I think because it's a Saturday night here in the Singapore time zone, so in Europe now is probably in the mid-afternoon, around 3 p.m. And in the east coast of the United States, I think it would be around 10:40 in the morning. So I don't know. Really depends on whether or not there's going to be anybody watching. But yeah. So anyway, we're just setting up some of the two chains and we'll take it step by step. Later on during this live session, I may need to excuse myself for a little while, and need to sort of take something downstairs to pass to someone, and then I'm coming back up again. From the looks of it, it does look like it's installing a lot of things. uh, Man, how much space is it going to use on my MacBook? Let's just take a look. Storage. Man, my space is dwindling. Oh, I always have a habit of trying not to use too much space on my laptop because normally, in an optimal running condition, you want to have enough space on your system, right? Leftover space. So, um, man, look at that. The decrease is fast. Yeah, and it's only halfway through the installation, so I so need an upgrade. I am gonna go and grab some water, and I'll be right back. So just hang on a minute, guys. Yeah, I'm just gonna mute the session for a little while. Okay, so I'm back. So once the installation is done, we'll restart the Simplicity Studio. I'm also going to kind of look at how much memory it uses. So I think it's helpful information for you guys as well. Storage 74 GB. So before installing the required files, I think I had about 80 GB of space. So it looks like I've used a total of about 5 GB plus so far, together with the Simplicity Studio installation, right? Program files. I haven't installed anything locally so far, so yeah, the memory space is only coming back up. So it's probably because they are removing temporary files. Right, so I think on average it's probably about five and a half GB, or 5.5 to 6 GB of space. So if you are working in this system, you need to take note that you need to have at least around 6 to 7 or 8 GB just to stand by, right? If you are working with the Simplicity Studio, all right? We will skip the tour, and then we will. Okay, so great. Now that we have refreshed, it's able to detect our starter kit. Okay, so let's go step by step now. So here it says that you have to make sure that the Gecko SDK is selected as the preferred SDK. So let's check that. The Gecko SDK, that's great. Okay, so there'll be list of demo software examples. So let's look at that as well. No, there seems to be software examples. So let's see what options are available anyway. Okay. So this is the Blink demo. So let's open up the Blink demo, explore the code a bit, all right? I'm going to be seeing this for the very first time myself. So, okay, so they got a couple of demos here. They have the segment LCD controller example, humidity temperature demo. Let's widen the Micrium OS Blink example. I'm very interested to sort of like learn more about the Micrium OS. But the evaluation kit, the evaluation license is only for 45 days. So, um, to the guys at Silicon Labs, yeah, just a reminder, I would love to have the license for the Micrium OS, the full license, so I can support the lab series, right? Okay, so let's try the Blink. Let's take a look at the Blink example. Mm, hmm. I have no idea what is this for. Um, Run. Do not get MCU. Okay. Okay, so the demos is described here are pre-compiled, enabling them to be downloaded and run immediately without opening the associated project and compiling it. So example codes, example projects, this thing is this, or source code, so they can be open ID, modified, build. Um, okay, so under getting started in Launcher, scroll down in the software examples column, you'll find the, okay, this is the one. Click it and say yes. Hmm. Mm, Honestly, I'm trying to figure this out. Mm, okay, so for examples, now it's opening in the Simplicity IDE. Yes, awesome. Some of you might feel like the font is really small, so let's adjust the reference. Okay, colors and fonts. Let's adjust the font and make it a little bit bigger. I have a bunch of really good programming code fonts, and if you're interested, you can let me know. Some of them are actually free, so there's no licensing issues. So I can share them with you if you want to. I actually like the BP type, right? Um, Sometimes as well, can use it. It's nice code. The Mingo code is nice too. Korea Prime is also not bad. QR code is the one that is quite nice because it allows you when you do the bigger than comparator and all that kind of stuff. They actually would have a dedicated symbol that they created that is meant for programming, which is really really nice. So let's make the font bigger. So frankly, I'm looking at all of this for the first time myself, so it does seem a little bit overwhelming. Uh, Maybe we will close this project. Just look at the Bing example, shall we? Let's start with something simple. That was a little bit too complex and a bit overwhelming for me. Okay, so let's just explore the coding a little bit. Delay would be delayed the number of seconds, I assume. So when you look at this, obviously this is the LED toggle to turn off and then turn on. Sysdig config. This is familiar because while learning about the ST microcontrollers nuclear development boards, I did learn a little bit about this, when working with STM32. So this is like the clock. Oh, I really like this. The mouse over will give you information about this function. This is awesome. Hey, this is really good. You know, I really like this. Oh, this is so good. This chip init is so we look at if the 32-bit series is defined eco-friendly, and so that's basically to initialize the chip itself. So you might be wondering what this is. If you're not familiar with C++, this is basically a function prototype. So you need to put a function prototype because if you don't put a function prototype and you put your custom user functions after the main block and you try to call it, the system will not recognize the function exists. So you need to put this right at the top. Right, so that's one use of the function prototype. It's a very practical explanation. It's not a theoretical one. So the theoretical explanation can be quite different. Okay, so oh, I feel like I got ringing in my ear right now. Okay, so let's look at documentation. Okay, so let's try this demo. Uh, so that now that we have seen this, okay, let's play a little bit with this. We change the delay to 2000, which is 2000 seconds. And then, what is this? How do we compile it? Okay, let's try debug. Okay, so here we get the run as, all right? So let's build the project first. Okay, everything is good. Build is finished. Let's run as the Silicon Labs ARM program. Guys at the Silicon Labs, thank you so much for creating Simplicity Studio. From the overall look, as a software engineer background, right? Looking at this is very familiar for me, so it's easy to navigate. And I think for people who are new or they are learning about how to use the TinyGecko or any products from Silicon Labs that uses Simplicity Studio, I think it is a really, really easy tool to navigate. Obviously, this is just my like sort of like getting started and working with your product. So with the Silicon Lab product. So I never really go into the theory of using the interface, but I'll probably dedicate one lab series session or few lab series sessions during the official lab series for Silicon Labs. And then, during those few sessions, we will actually explore how to use the UI and interface, the integrated development environment. All right, so let's click and compile it. One of the things that this happens, which I have no idea why. Okay, I'm honestly not very sure if it's even compiled. Uh, I don't know, guys. It doesn't seem like it's compiling. Oh, yeah, I'm not sure why this is happening, guys. Okay, so I'll probably have to go and figure this out somehow. This is not working. Hmm, it's supposed to work, but anyway, let's run this demo instead. All right, let's see what happens. Hmm. I have no clue. Let's try again. Hey guys, so basically, okay, at least we got the IDE up and running. We managed to take a look at some of the example programs that are available. Um, Somehow can't seem to get Flash programmer unlock debug access. Okay, it does look like we managed to erase everything in the chip. Let's see if we can debug. Let's try the Blink application. Okay, let's close everything and start again. Mm, close project, close project. Let's quit and then let's try again. Oh, I have no idea why this is not working. Okay, let's try to do it manually. Do we have to copy all the files? Okay, so let's copy the heads file. Okay, so that should flash program. I think so. Hmm. Hmm. Yeah, I just erase everything. Oh God. That's bad. Shit. Okay. Something is wrong, I think. Oh, thank God. Everything's okay. Well, it looks like there are no errors. Looks like the programming is working. Yay! I think, guys, if it doesn't really work in the first time, you probably need to restart your IDE and try again. I'm definitely going to take a photo of this and post it. Okay, let's look at the documentation and see what we need to do. What's the next step? Okay, so we can look for the file, open, program. That should work. I don't see anything. Mm, mm, Okay, I officially have no idea whether it's working or not. Honestly, I don't know what's going on, guys. The LCD is should show something, but I don't see anything. Let's try the Bloom project instead. Okay, so it looks like the LED example is working. So I'm going to switch over to the hardware view. All right. Okay, so if you can see this LED 1 and LED 0 is currently blinking. So I suppose the code example is working. Hmm. So if we modify the code, all right, let's go back to the screen and modify the code and see what happens. Okay, let's modify the code. Uh, let's start the debug. Okay. If this is to toggle LED 0, let's try toggle 0, delay, 1 second, and delay, 1 second. Okay, so logically, I feel that this would toggle LED 0 on the development board to turn on and off every 1 second. Right, so we're gonna give it a try and see what happens. Okay, so LED 1, we turn it off. I'm going to show you in a second the hardware. This is actually working now, so uh, we will toggle the LED so it stays off. However, we will emit the LED driver so that we can work with the LED during the program. And then we will run. Okay, so let's look at the hardware now. Okay, so you can see that LED 0, sorry. Okay. LED 0 now blinks every 1 second, and that is exactly what we were trying to do. So yes, we are successful. We managed to get our very first code example working. So I'm gonna just take a photo of this, and I'm gonna plug up the USB cable. Let me close the studio environment. I'm gonna unplug the USB cable and then switch it to battery mode. I'm gonna move it closer. Okay. Then I'm gonna focus Okay, so you can see that LED 0 down is blinking according to the program that we modified from the example. So yeah, we got it working. All right, so I know that I got stuck a little bit for a while earlier. So this is awesome, this is amazing. We finally managed to get it to work. So we're gonna have more videos and sessions, live sessions to talk about how we can understand the coding. I'm going to learn the coding myself, the framework, and everything else that is needed with the SDK to work with the various development bots, as well as this development bot by Silicon Labs. All right. So thank you very much for watching, guys. If you have watched the live session, if you tune in, thank you for that. If you're watching the rebroadcast, I hope that you will gain something from this video as well. Yeah, I'll probably do a pre-recorded video as well, at a later time. Um, yeah, just to give you the more condensed version. Right. Take care, guys. Thanks a lot. Bye.